Imagine you're standing in a wide field. The sky is clear, not a breath of wind. It is quiet, almost eerily quiet. But you have no idea what's happening, because at that very moment the Earth stopped rotating. No slow braking, no advance warning, just stand still. This may sound harmless, but it is a physical nightmare, because even if you feel motionless, you are actually rotating with the Earth at incredible speed. At the equator, this is over 1,600 kilometers per hour. That's faster than a bullet, and more than twice as fast as a passenger jet. When this movement suddenly ends, your own body acts like a bullet. Everything that is not firmly attached to the Earth's crust is hurled with full force. To the east, buildings collapse. Cars are torn across the asphalt. Planes crash. People instantly lose their balance. And the oceans? They break over the coasts in huge, kilometer-high tidal waves. A gigantic mass movement of water and violence. It would be as if the entire world were crashing into an invisible wall. The beginning of the end, in just a fraction of a second. And that is just the first effect. Just a few hours after the standstill, the world begins to change, because something we take for granted is suddenly gone. The change between day and night. Normally, the Earth rotates once in 24 hours. This causes the sun to move across the sky, making it light and then dark again. But when the Earth stops rotating, the sun simply stops, forever. On one side of the Earth, it is now eternal day. The sun stands motionless in the sky, relentless, scorching, deadly. On the other side, endless night, pitch black, icy, silent. Within a few hours, temperatures on the day side rise to over 60 degrees Celsius. In some regions, temperatures may even reach 100 degrees, enough to melt asphalt. The oceans begin to evaporate. The soil dries out. Plants die. On the night side, the opposite happens. The temperature drops rapidly. Without sunlight, it gets colder than Antarctica within a day. Lakes and rivers freeze. The atmosphere begins to redistribute, from hot to cold. The result? Powerful winds that race through the twilight zone at hundreds of kilometers per hour. This zone, where day and night meet, becomes the only habitable strip on Earth. But even there is chaos. Tornadoes, dust storms, extreme weather. Humans, as adaptable as they are, suddenly find themselves on the brink of survival in this new world. In this new world, it is no longer about progress, but about survival. For humanity, the standstill of the Earth becomes the ultimate test, because the body is not designed to exist under extreme conditions. Even at temperatures above 40 degrees, our circulatory system begins to fail. On the day side of the Earth, temperatures now exceed 100 degrees Celsius in some places. That's enough to liquefy asphalt and dehydrate people within minutes. On the night side, it is no better. At temperatures below minus 60 degrees, unprotected skin freezes in a few seconds. And we're not even talking about radiation, because when the Earth stops rotating, it slowly loses its magnetic field, the protective shield against solar wind and cosmic rays. Without it, we would be constantly exposed to deadly radiation. Results from space medicine show DNA damage can occur after just a few months, which massively increase the risk of cancer and cell changes. In this world, only a few places would remain habitable, maybe deep underground, or in strictly controlled biospheres with an artificial atmosphere. Humanity would be forced to reorganize itself. No more free life, no more natural rhythm, only light, shadow, and the question, how long can our body endure this? Okay, wait a minute. If all this depends on the Earth standing still, a simple question arises. Earth rotate at all? The answer lies a long way back, over 4.5 billion years ago, during the formation of our solar system. The Earth formed from a rotating cloud of gas and dust, and because there is no stopping in space, it maintained its rotation simply by the law of inertia, and that continues to this day. In fact, the Earth loses a tiny bit of its rotational speed every day, mainly due to the tides. The moon's gravitational pull acts like a brake, but don't worry, it takes about 50,000 years for a day to lengthen by a single hour. That means the natural standstill would take billions of years. But what would have to happen for the Earth to suddenly stop? A realistic scenario. Difficult. It would require incredible energy. For example, a gigantic impact, an asteroid several thousand kilometers in diameter, or a gravitational field, such as that of a black hole, that abruptly slows us down. Both would probably not only stop the rotation, but destroy the whole Earth. In short, an immediate standstill is theoretically conceivable, but practically the end of the world. The Earth stands still. One half glows in eternal sun, the other lies in eternal darkness. And somewhere in between, man tries to survive. But is that even possible? Actually, yes, at least in theory, because there is a narrow strip on the planet that neither burns nor freezes, the so-called twilight zone. Here, the light of the eternal sun meets the cold of the eternal night, a narrow belt between extremes. On exoplanets, this zone is also called the Terminator Zone. And that is exactly where our last refugees would be. But even in this zone, life would be a constant struggle. Temperature differences, strong winds, unstable atmosphere. We would have to learn to live completely artificially. Scientists have already developed functioning biospheres, closed self-sufficient life systems, in Antarctica, on space stations, even as test models for Mars. They provide water, food, and oxygen without any external influences. And this technology would be our only hope. We would build huge domed cities, protected from radiation, heated, ventilated, with its own agriculture under UV light. Artificial intelligence would help keep the system stable. Robots would carry out maintenance outside the domes. We could generate energy through geothermal energy or nuclear fusion, because solar energy would be difficult to plan in this new world. But even if we can do that technically, the question remains, how long can people endure this psychologically? No natural day-night rhythm, no seasons, not a sky as we knew it, only light or darkness. And in the middle of it all, a species that must adapt or perish. Maybe we could survive, but it would no longer be the life we know today. When the Earth stops rotating, we not only lose day and night, we lose our rhythm, our balance, our home, because rotation is not just movement, it is a system that controls our climate, sets our time, our lives possible in the first place. Without them, everything falls apart. The atmosphere, the oceans, the biosphere, and ultimately, humanity itself. We saw what happened in the first few seconds, what would follow after hours, days, years, and what we would need to survive. Technology, adaptation, hope. But perhaps this thought experiment shows us something else. How fragile what we take for granted is. A rotating planet, a sunrise, a gust of wind. All of this is no coincidence. It's a gift, a precise interplay of gravity, inertia, rotation, and time. A system that we cannot control, but are allowed to use. Perhaps the true knowledge does not lie in whether we could survive the standstill, but in making ourselves aware again how much exercise is necessary so that we can even stand still. The Earth rotates, and with it, our lives turn. As long as things stay this way, we still have time. Time to protect this world before at some point it really stops moving.